Today we shall look at the calculations on non-right angled triangles. What we calculate is the length, or we calculate the angles that are in a triangle. Now, before we look at the non-right angled triangle, let's look at what we already know. The right angled triangles. What calculations and how do we make them? We can be required to find the length in a triangle. And if we are required to do so, we just simply use the Pythagoras theorem. And here's an example. If you're supposed to find x here, and then you're given this, the longest side always stands alone. So 13 squared is equal to that, and then you make x the subject. Then number two, still on the length, we can use SOHCAHTOA provided we've been given an angle in the triangle. So in that case, we still have to find x there, and then we're given an angle at one side. So we use opposite hypotenuse, which means we use sine. So sine 60 is x over 14, and therefore making x the subject, x is 14 sine 60. Number two, if we have to calculate the angle in a right angled triangle, we can use simply SOHCAHTOA. Here's an example. We're given this length, that length, we need to find this angle. So we check, we are given the adjacent versus the hypotenuse. So cosine is what we use. So adjacent of hypotenuse and then cos inverse. That gives us the angle, which you can find using a calculator. We shall now look at the first rule on calculations of lengths or angles in triangles that have no 90-degree in them. Okay, and the first rule is what's called the sine rule. The sine rule states that if you have a triangle ABC, whereby the length facing angle A, we can call this angle A there, the length is A, and the length facing angle B, so this is angle B, facing is B, and then similarly C there. It says the ratio sine A, sine of this angle, divided by this length, is equal to sine of this angle divided by that length that's facing it. Similarly, it is equal to sine C divided by C, just like that. Or you can just prefer to write them separately in equation form like that. You say A over sine A, you can write the letter on top, the length divided by sine the angle, called letter, or the length divided by sine the angle. Or you can pair up A and C like this, or you can pair up B and C. So whichever is going to work. Now let's look at this example. Well, this one, because there's a 90-degree angle here, you are not necessarily required to use the sine rule. You can just use the opposite over hypotenuse, which is the sine formula. But just to check if it works, we can say the length we're looking for is facing 90, so x over sine 90 equals 28 over sine 30 there. And then we make x the subject, so we take the sine, then we put it here, sine 90 comes there, and then we just use a calculator, you find that. Second example, if here we're given this is 150, we're not supposed to find this. Now what you need to know about the sine rule is that there must be a complete pair. So there is a complete pair. 150 degrees is facing 13, could be centimeters or meters, whatever the units are. And then here we have 20 facing what you are looking for. So our formula would be x divided by sine 20 equals 13 divided by sine 150, and then we make x the subject. just like that. What if we wanted to find the angle? In this case, we have this triangle. Sometimes you can be given these. Any letter can be used. Okay, so the complete pair is this one here. So 18 versus 50. And then what we are looking for is the angle, which is facing 12. Because we're looking for the angle, it's better we start by saying sine angle rather than having sine in the denominator. So what we're looking for, it's better be in the numerator. So sine 12, sine x, the angle, divided by 12, the length, equals sine 50 divided by the length 18. And then we take 12 to this side, it's dividing, it's going to multiply there. Then now we have to find sine inverse of that whole thing. So sine inverse of 12 sine, you just punch this in your calculator as it is, and it gives you 30.7. Thank you for watching.